Okay, so we already finished until this part. We already know that whenever we have the missing value, if we want to delete means we want to remove or we want to ignore. So if the data is in the if the missing values are in order like this one or like this one, then there will be no issue if you delete. There will be no issue if you remove it. But if the missing values scatter like this, then you will have a big loss when you remove the data. Okay. Therefore, there is another way if you want to handle the missing value. So when you have missing value like this one, you can fill in manually. Okay. So as we learned before, if we fill the missing value manually, it is tedious and invisible. Let's say I have this data. Brian, the gender is male, he lives in Yongin. Okay, I know that Yongin is in the province of Gyeonggi. Then, of course, I can type Gyeonggi. But if there are so many missing values, you need to type one by one. The second data, for example, Jessica, female, Gyeonggi, but there is no city. So there are many cities in Gyeonggi. What should I fill for this data? Maybe I can assume that if this data is about the student data, maybe they live in the same city. So I can put Yongin. But that's only a guess. And this also an issue. DOB. DOB is date of birth. If you see the structure is maybe this is the day, month, year. But here we have only day and month without year. So some structure is missing. How can we fix? If you want to proceed with your data analysis, of course, your analysis will be not good because some data are missing, some data is missing, and this data is not correct. You can fill in manually. You can put Gyeonggi here and you can put Yongin here, and maybe you can assume that if they are in the same batch, if they enter the university in the same year, maybe Jessica was born in the same year. So I just put 86. So that's an assumption, and we fill this data manually. We have only two. We have only two data, so it is easy. But if we have 1 million data, it's not easy. The other way to handle the missing data is to fill in automatically. How we can fill in automatically? For example, I can give a global constant. So if the data is missing, I can just put unknown. I don't know.
So yeah, you can put unknown to all missing value. If the attribute is numerical, then you can put the min, for example, to replace the missing value. Or if the attribute min for all samples belonging to the same class. So we call this is more smarter. What does it mean? So you know that we have the iris data set. We have three kind of flower: setosa, versicolor, and virginica. Let's say I check the data and I found out that one of the sepal length is missing. Okay, then I will check what is the flower name. And I know that the flower name is setosa. Then I will check only the mean of the sepal length of the setosa, and then I will put the mean of the sepal length of the setosa in that missing value. So it will be more precise. It will be more accurate rather than using the population mean. So we can say that the attribute mean is the population mean. But this one is the sample mean or the class mean. A particular class, there will be attributes. So you just measure the mean of that attribute in a particular class. Or we can check the most probable value. We can use some formula like Bayesian formula or some probability with decision tree. For example, the probability of an adult male to get salary 5,000 US dollars. Or maybe we can use mood for categorical attribute. So if we know there are many male than female, then if there is a missing value on the gender, we can put the mood. Mood is the most frequent value. Okay. So this is the way to fill in automatically. We can use some statistical properties. Now, let's see this example. The yellow color is the missing value. Okay. Now we have 5 data. Bob, there is no city name. Jessica, there is no hobby information. And then Charlotte and Eden, there is no information about age. So if we delete, let's say, okay, I just remove the data because the data is not completed. Then it means you will delete all those 4. Because there is one missing value, there is one missing value, missing value, and missing value. So you will lose 80% of the data. And only one data is remaining. So it's not good for your data analysis. Therefore, we can try to make a good data on this, and on this side. How? Let's say in the city, there are many cities. So we cannot make assumption. We do not know where he lives. So we can just put unknown. So every missing data, we put unknown. What about the age? It is numerical attribute. Then we can put the average. So 20 plus 23 plus 22 divided by 3. Okay, so we can have 20 plus 23 plus 22 divided by 3. So we can get 21.6. Then you will give questions. Professor, there is no age with comma. Yes, okay. But this is only a replacement value. So you can define your own value. Maybe you want to round up the value to 22. That's okay. Or you want to round down the value into 21. That's also fine. But we can say that this value may be around 21. What about the hobby? So we have reading, we have hiking, we have piano. So I can assume that because there are a lot of piano, then I can replace this missing value with piano, because this is the most frequent value. Or sometimes, if you know more about the data mining, we can figure out this female and all female have the hobby piano. Then maybe her hobby is also playing piano. So if we know the decision tree, there might be a high chance that her hobby is playing piano, because the gender are same. So this is just a simple learning check. Okay. So how many methods are there to handle missing data? We have at least 3. Okay. What are they? First is just remove or ignore the data. 2 is fill in manually. And then 3 is fill in automatically. And when you do the fill in automatically, there will be many options. If your data is numerical, you can use min, or you can use the sample min, okay? Or you can use the class min. If your data is categorical, then you can use move. Or if it is numerical, you can have the probability. The same with the categorical, you can also have the probability, and so on. Okay. So when you fill in the missing data automatically, what kind of measure is good for numerical value? Mean or minimum or maximum or standard deviation? What is the good method to fill in numerical value? Is the minimum, maximum, standard deviation? No, the best is mean. Okay. For numerical value, we can say that the mean is the best option. When you fill in the data automatically, what kind of measure is good for categorical value? Mean? Yeah. In categorical value, there is no mean. In the categorical value, there is no median. So the best option is mode. Okay. Okay, let's go to the orange. I think I put the data. Okay. I put the data on the e-class so you can download the data. When you download the data, you can put in your own folder and then you can open data by clicking this button, and then you can select, in my case, I put it in this folder. There is data, student data, and I can click this data and we can open it. So we have 5 instances, and then it mentioned there are 2 missing 2 features or 20% missing values. Most of them are text. So if you want to check the details, you can go to the data table. So here, the orange can immediately give you the result. The question mark is the missing value. And this column has gray color. Why? Because orange automatically detect name, city, and hobby as meta. Okay. Meta means there is no meaning to do the analysis because there are so many keywords. Usually when we use this text, when we have this kind of text, they will recognize as the unstructured data. You still remember? Unstructured data. The data in the text is not structured because it can be very long and there will be many words. So it depends on how you can define this attribute. So you can change this into categorical. You can change this into categorical, and you can check other option. Let's say that I have a confidence that this attribute is a feature. So you can change this into a feature. If you put this as a meta, there will be no analysis. Okay? Or the analysis will be different. For now, let's just put the type as only 2, categorical and numerical. So I will put this one as feature. Okay. So all are the features, and then I can apply. When I apply this, then the gray color now has been removed. So we can analyze those data. Now let's check. We can pre-process. Okay, there is we can pre-process the data. And Orange already prepared a lot of pre-processed tasks. There are some tasks here, so we will learn more later how to discretize, how to continuize, and select relevant features, select random features or normalized features, randomize, and etc. Okay. So in this case, I would like to impute missing values. We want to handle the missing values. The keyword is impute. And in this step, there are three options. Whether you want to do the average or most frequent. In orange, these two are combined because they can automatically check if your data is categorical, they will use most frequent. If your data is numerical, they automatically calculate the average. The second option is replace with random value. Yeah, it depends on your data. Maybe you will need this random value, but most probably you will do with the average. Or you can remove rows with missing values. So if you remove rows with missing values, you can check that only one data remains. If you do with the average or most frequent, then it will be like this one. The age is 21.67, the city. So why Ansan? It's randomized by the audience. Maybe because A is the first. Okay? Usually they have some standard. Because of the randomized, they will use the sequence or the order. So starting from A, B, C, D, because Ansan is starting with A, so Ansan is chosen to replace the missing value. And then, yeah, here it has been replaced with piano because it is the most frequent. How if we replace with random value? So, yeah, the orange just select any values and then replace the missing value with the random values. The values that exist in this column. The value that exists in this column, and it is random. We can use a particular way to do the input. Okay. We can select the impute. When you go to the impute, we can select a particular method for a particular attribute. So the default method means it will be valid for all attributes. Do not impute, or you can choose the average or most frequent. You can choose as a distinct value, or you can use some more advanced way with the simple tree. So we will learn this one later. Or we can put random values, or we can remove instances with unknown values. So this method, those methods are for all attributes. We can make a specific method. Let's say I know that there are some missing values on the edge. For the edge, I would like to use the average. And then there's also missing value on the name. For the name, I would like to put the distinct value. Oh, sorry, I think name, all names are available. Okay. City. So for the city, I would like to give a distinct value, for example. And for the hobby, maybe I would like to give a fixed value. So you can make a different way for every attribute. And you can click on this attribute setting. So if you apply this, then you can see now the age is based on the average. The city filled in with the NA because we want to put a unique value. And then the hobby has been filled with hiking because we put the value hiking in the input. Okay, so this is the information for every specific attribute. Okay, any difficulties? Sorry, the distinct value and distinct value or fixed value? Yeah, it depends on you. Okay, in the distinct value, it means they will give you like what I explained to you. We can put like unknown. So in this case, the orange give NA, not available. But for fixed value, yeah, you can determine what are the value that you want to put. So here you can have options. This option is based on the categorical value that exists on your data. Okay. Okay, good question. Thank you. Any other questions? Yeah, maybe this data is very simple. Yeah. But when you have a real data, it will be more complicated to handle the missing values. Once you have this framework, or once you have this workflow, you can save. Okay, you can save this one, and the file name is OWS, Orange Workflow. And yeah, let's say you want to save it in this folder. Okay, just practice missing values. So whenever you have an assignment, if I give you an assignment and if you need to do the data analysis with Orange, you can just submit the OWS file. Okay. So the file will be here, practice missing values. Okay. So you can upload this file for your assignment. So if I give the assignment about Orange. Oh, sorry, I didn't put this one. I think I will explain this one later. I will not use this data set. Anyway, let me skip this one. Sorry. So after we have the missing values, we need to think about the noisy data. One example about the noisy data was about the date of birth. So this one is noisy. It is not missing. You have the data, but the data is not correct. So we call it noisy. So noisy or noise is about the random error or variance in the measure variable. For example, this one. When you want to know the weight of an apple, when you put the apple, but the weight show in minus. So of course, this is an error. Okay. The incorrect attribute values may be due to the faulty data collection instruments or maybe data entry problems. If you look at the date of birth data, it might be the data entry problems. Data transmission problems. So maybe the internet connection is limited, so some data has been sent, but it is not correct. Technology limitation or inconsistency in naming convention. So how to handle the noisy data? First, we can check with binning. There is a method called binning. We can sort the data and then we can partition into equal frequency bins. And then we can smooth by means or smooth by median and etc. So there is an example we can see later. The second way is to do regression. So the noisy data, we can do regression. What is the Korean? Hegi bunseok. Okay. So we can do the regression by fitting the data into the regression functions. Let's say I have this regression function. So if the data is too far from the model, we can remove it. Or we can say that the data is noise. Or we can do clustering. So we will learn later about clustering. We can detect and we can remove the outliers. Or we can combine computer and human inspection. So the computer can see, but sometimes human should involve. So the computer may detect the suspicious values and finally checked by human. Okay. So it should be combined. So these three are the most common way to remove the noisy data, but there can be another way. Okay. First is about binning. What is the meaning by binning? In the concept of discretization, discretization, discrete. What does it mean by discrete? Discrete is another name of categorical. Okay. So let's see. I have age. I have the data 25, 30, maybe 41, 53, 65, maybe 76, and so on. Okay. So I can make it as a discrete. How? I can say that the person lower than 50, maybe I can say they are young. Okay. And the person who are more than 50, they are old. Okay. So I can put the discrete value, young and old. So that's the meaning by discretization. And we can do the discretization by binning. There are two methods. The first is equal width and the other is equal depth. Equal width or equal distance. We can divide the range into n intervals of equal size or uniform grid. And if A and B are the lowest and the highest value of the attribute, the width of the intervals will be W equals to B minus A divided by N. So the equal width is the most straightforward, but outliers may dominate presentation. And skew data is not handled well. So we will check the examples. Or maybe let's go to the example first. I have this data. This is the price in dollars. $4, 8, 9, 15, 21, 21, 24, 25, 26, 28, 29, and 34. Okay. So how many data do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we have 12 data, and this data has been sorted. This is the minimum, and this is the maximum. Now, if we want to do the equi-depth or equal frequency, let's say I want to make 3 pin. Okay, I want to make 3 pin. Do you know pin? Pin something like place. Okay, like the place. So I have 3 places, and this place is like one category. So I have 3 pins, and I want to make it as an equal frequency. So we know that we have 12 data. If we have 12 data, then we can put 4 data in the first bin and the other 4 in the second bin, and the other 4 will be on the third bin. So this is pin number 1, pin number 2, pin number 3. The idea is like this one. Pin number 1 is 4, 8, 9, 15. Pin number 2 is 21, 21, 24, 25. And pin number 3 is 26, 28, 29, and 34. Using this pinning method, we can find some noise data. There are 2 ways. In this case, we use the smoothing. Smoothing, I would like to check whether there is a noise or not. So in this case, I would like to use smoothing by pin min. As I mentioned to you, we have pin number 1, okay, and then we have pin number 2, and then we have pin number 3. And then for every pin, I would like to check the min. 4 plus 8 plus 9 plus 15. So the min is 9. So we make the smoothing for every value here. We replace it with the min. 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 And then the pin number 2, we can also do the average. The average of this one is 23, so we replace its value with the 23. The value here has a mean of 29, so we replace the pin number 3 with 29. We call this is smoothing. We want to smooth the value, so we can check whether there are some outliers or not. We also can do smoothing by pin boundaries by looking at the closest value on the minimum or the maximum. How? So here, 4. It is the maximum. The minimum. Okay. So we will keep the number 4. How about second? We put the minimum because 8 is closer to 4 rather than 15. If we check the distance, 8 and 4, we have the distance of 4. But if we check the distance 8 to 15, the distance is 7. So it is far from 15. So we make the smoothing value by the lower bound. We set into 4. What about 9? 9 is closest to 4 or 9 is closest to 15? It is closest to 4. So we put the 4. 15 is the maximum. So we put maximum. What about the pin number 2? 21. Okay. And 21. Okay. Because those two are the minimum. And 24 is closest to the maximum. Is closest to 25. So we set the smooth value into the maximum, which is 25. What about the pin number 3? 26 is the minimum, and then 28 is closest to 26. 29 is closest to 26. So we smooth, we call it smoothing. We smooth the values with the pin boundaries, and we choose 26 for the value 29. 34 is the maximum, so we put the maximum 34. What about the equi-width? So the equi-width, we want to check whether they have the same width or not. So let's say I want to make 3 pins. I want to make 3 pins. So the same, we can use this formula. If A is the lowest and B is the highest value, and then N is the interval of equal size. So it means the number of pins that you want to create. So the width of interval will be the W equals to B minus A divided by N. B is the highest, A is the lowest, and then divided by the number of pins that you want to set. What is the maximum from this data? 34. 34 minus the minimum, the lowest value, which is 4. And then how many intervals that you want to set? So I want to make 3 pins. So divided by 2. Then I have 10. So 10 will be the width. How can we check the width? We have the value 4 as the minimum. So we will make the width of 10. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 4 until 13 will be in the pin number 1. And the next width, 14 until 23, it will be in the pin number 2. And the next 24 until 34 will be in the pin number 3. So you can check 4. Okay, this is in the pin number 1. 8, it is in the pin number 1. 9, it is in the pin number 1. What about 15? 15, it is in the pin number 2. 21, it is in the pin number 2. 24, it is in the pin number 3. So the pin here with equi-width will be different with the equal frequency. Okay. That's the pinning method. So the equal depth or equal frequency, we just divide the range into n intervals, each containing approximately same number of samples. And then it is good data scaling. But when we manage categorical attributes, it can be tricky. So usually we use this one for the numerical attributes. And when we are dealing with the noisy data, we can also do cleaning. There are some methods, we call it, this is the data discrepancy detection. The data discrepancy detection, there will be some methods like you can use some metadata. The metadata means, it depends on the domain, it depends on the range, it depends on the dependency, or it depends on the distribution. Let's say, if it is in South Korea, of course, the domain will be only in South Korea. Range. If it is about age, then of course there will be some range, 0 until 100 years. If you have age like 445, of course it is out of the range. So it is noisy. Or we can have the dependency or some other distribution. In this case, we need to check the uniqueness rule, or we need to check the consecutive rule, or we can check the null rule. Some of them might be null rule. If it is null, then you cannot fill in anything. We can use some commercial tools. Maybe in Korea, whenever you input your address, there will be some very good tools to put the knowledge of the address in Korea. You can put the address name, or you can type Musendong, and then it will show you all the possible address. So that's the commercial tool, or we call it the data scrubbing. You can use the postal code, or you can have spell check. If you use Hangul, or if you use Microsoft Word, if you type something, if it is error, then there will be the red line. So that's the data scrubbing. Let's see, in the postal code, we live in Yongin, 17035. But the city is Seoul. So it is not consistent. 17035 is the postal code in this area. But the city is Seoul. So this kind of data is noise. We can use the data scrubbing for this issue. Or we can do the auditing. This data auditing, we can analyze the data by discovering the rules or relationship to detect the violators. So some correlation and clustering to find the outliers. So like this one, this is not consistent, or this is not based on the rule. In Korea, the postal code should be in the 5 numbers. So if it is 6 numbers, of course, it is out of the rules. We need to clean this kind of data. Okay, let me stop here first. Let's have a break.